Hello everyone. In this video, we will be solving questions on functions. So without further ado, let's get down to it. So the first question we'll be taking a look at is this. So we have to identify whether each of the following functions are even, odd, or neither of them. So the first function that we have here is x raised to the power of 3 plus 3x divided by 1 minus x raised to the power of 4. The second function is sine squared x. The third function that we have here is tan x divided by 1 plus x squared. And the fourth function that we have here is 1 plus x raised to the power of 4. The last one, and probably the most interesting of them all, is this function where j naught of x is an arbitrary function. That is, we don't know what function it is. So before we solve this question, let's establish what an even function and an odd function is. So a function is said to be even when f of x has the same value as f of minus x. That is, on substituting minus x into the function, we are still going to get the same value. And a function is said to be odd when f of minus x is the same thing as minus f of x. So substituting minus x into the original function, we are going to be having negative of the original function when we get it. When a function doesn't satisfy either of these conditions, then we say that the function is neither even nor odd. So let's use this idea to solve these questions. So in the first case, we have that x raised to the power of 3 plus 3x divided by 1 minus x raised to the power of 4 is equal to our function. So substituting minus x, we have minus x raised to the power of 3 plus 3 multiplied by minus x divided by 1 minus x raised to the power of 4. Sorry. So we have f of minus x to be equal to minus x raised to the power of 3 minus 3x divided by 1 minus x raised to the power of 4. And this gives us minus, into brackets, x raised to the power of 3 plus 3x divided by 1 minus x raised to the power of 4. So it shows that f of minus x is the same thing as negative of x. Therefore, the function in this case is an even function. Sorry, is an odd function. So let's take a look at the second function that we've been given. So in the second function, we have that g of x is equal to sine squared x. And sine squared x can be rewritten as sine x raised to the power of 2. Therefore, when we find g of minus x, we have sine of minus x all squared. Let's recall that sine of minus x is the same thing as minus sine of x. from our knowledge of trigonometry. So you can write g of minus x to be equal to minus sine x raised to the power of 2, which is the same thing as sine x all squared, which gives us sine squared x. Therefore, since g of minus x is the same thing as g of x, we say sine squared x is an even function. The third question that we have here is tan x divided by 1 plus x squared. Let's represent this as h of x. So this means h of minus x becomes tan minus x divided by 1 plus minus x squared. So this equates to minus tan x from our knowledge of trigonometry divided by 1 plus x squared, and this is minus h of x. So since h of x, since minus h of x is same thing as h of minus x, we have that tan x divided by 1 plus x squared is an odd function. So let's take a look at the fourth question we have here. We have 1 plus x raised to the power of 4. Let's represent this as p of x since it's a polynomial. Just decided to represent it that way. You can represent it using any arbitrary letter actually. So an expansion, you can use the binomial expansion or you can use the Pascal's triangle. For if you're using a Pascal's triangle, you have the coefficients to be 1, 4, 6, 4, and 1. So therefore, 1 plus x raised to the power of 4 is the same thing as 1 plus 4x plus 6x squared plus 4x cubed plus x raised to the power of 4. So if we find p of minus x, p of minus x will be equal to 1 minus 4x plus 6x squared minus 4x raised to the power of 3 plus x raised to the power of 4. So we can see that p of minus x is not equal to p of x, and it is also not equal to minus p of x. So therefore, 1 plus x raised to the power of 4 is neither even nor odd. Another thing I want to bring to our attention is that when you have a polynomial function and you have even powers of x, it's evident that on substituting minus x, you still get the same answer. So when you have even powers of x in a polynomial, it's an even function, and when you have odd powers of x, as you can see here, it's going to give you an odd function. So let's take a look at the final function that we have there. We have j naught of x squared, and we've been told that j naught of x is an arbitrary function, and we have no idea what that function is. So if we allow f of x to be equal to j naught of x squared, let's try to find f of minus x then, which means f of minus x will be equal to j naught of minus x squared. So it means f of minus x is going to be equal to j naught of x squared. So this shows that f of x is equal to f of minus x. Therefore, g naught of x squared is an even function. And this is regardless of whatever function g naught of x is, because we've just established that we don't need to know the function that j naught of x is to be able to determine whether j naught of x squared is an even or an odd function. Let's take a look at more questions. Let's take a look at the second question. You are required to find the inverse of the following function. So the first of the functions is x minus 1 divided by 2x plus 3, and the second function is x squared plus 2x. We have also been told that we can restrict the domain if necessary. Let's try to solve this. When we are required to find the inverse of a function, just like a function has a domain and a range, the domain is acted upon by the function to get values within the range of the function. So in finding the inverse of a function, you are applying the inverse function to the range to get the domain. So it's like when the function is in x originally, then you get your values of y. Let's assume that's what the function is represented by. Let's say y is equal to mx plus c or any random function. So when you apply the function to x, you get values of y. What the inverse function seeks to do is to get the values of x that have been substituted originally. So it's like you're reversing the process. And it's common that we say f inverse of f of x should give us x back. So it means by applying the inverse function to the original function, you should get the values of x that were substituted originally. That's what the inverse does. And it's also important to note that only functions that are one-to-one have inverse. I think the second question explains that better, and we'll see that when we try to solve it. So let's take a look at the first question. So let's represent our dependent variable as y. So y is equal to x minus 1 divided by 2x plus 3. So when required to find the inverse, what we try to do is we'll make x the subject of the formula. So when we cross multiply, we have y multiplied by 2x plus 3 will be equal to x minus 1. It means 2xy plus 3y will be equal to x minus 1. Then we can collect like terms and say 3y plus 1 is equal to x minus 2xy. By making x the subject of the formula of factorizing x in the right hand side, we'll have x multiplied by 1 minus 2y will be equal to 3y plus 1. So x now becomes 3y plus 1 divided by 1 minus 2y. It means if we have the values of y, that is the range of the function, we substitute it into this function, then we are going to have our values of x that we substituted originally. So we'll now write the function in terms of y by switching y and x. It means the inverse function now becomes y is equal to 3x plus 1 divided by 1 minus 2x. And this is going to give us the inverse of the function. We can check by substituting the original function into this to see if we are going to get x. So let's do that. So y will be equal to 3 multiplied by x minus 1 divided by 2x plus 3, which is our original function, plus 1 divided by 2 multiplied by 2x plus 3, sorry, 2 multiplied by x plus 3, I meant to write there. Then x minus 1 divided by 2x plus 3 plus 3. Sorry, there's a mistake here. So we should have substituted 1 minus 2x here instead of 2x plus 3. So let's correct that. This now becomes 1 minus 2 into bracket x minus 1 divided by 2x plus 3. So simplifying this, you can see that y will be equal to, or let me represent this instead as capital Y to represent the inverse of y, so there won't be a confusion in both of them. So if you have y here, capital Y, you have y here, and you have y here. So this becomes 3x minus 3 divided by 2x plus 3 plus 1 divided by 1 minus 2x minus 2 divided by 2x plus 3. So on simplifying this, we can see that the numerator becomes 3x minus 3 plus 2x plus 3 divided by 2x plus 3, then divided by the denominator, which is 2x plus 3 minus 2x plus 2 divided by 2x plus 3. So this is evident that becomes 5x divided by 5, and this gives us x. So this confirms what we want, that on substituting the original function into the inverse of that function, you are going to get x back from this place. So that solves the question, and that shows we've done the right thing. Now for the second question, we're told that y is equal to x squared plus 2x. Because it is a quadratic function, there are points where the values of y are the same for different values of x. So in this case, we say a function should have just a single value, one output, one input. That is the way it is. One input, one output. So like I said before, only a one-to-one function can have an inverse. This is because in a quadratic equation, if you have, say for instance, y is equal to x squared, the value of x equal to minus 2 and the value of x equal to 2, when it's plugged into that function, we are both going to be getting 4. That's fine, because one input corresponds to one output. When we find the inverse of such a function within the domain of x squared, it means if we want to find the inverse, we are going to be having, for each value of y, we are going to be having multiple values of x, at least 2 values of x, and that doesn't count for what a function should be. A function should have an input and just a single output corresponding to that input. So if we want to solve a question like that and we still want to find the inverse of the function, just like in this case, we would have to restrict the domain such that we wouldn't have multiple values for each input. In this case, if you take a look at a sketch of y, the function y is equal to x squared plus 2x, you would notice that it has a turning point at x is equal to minus 1. So it means we can restrict the domain at this point because values either to the left of minus 1 or to the right of minus 1 now satisfies the condition of function for the original function y is equal to x squared plus 2x and its possible inverse. So in this case, I'm going to be restricting the domain to the left, but it could be done to the right too, regardless. So restricted domain now becomes x is less than or equal to minus 1. That is from the values of minus 1 till negative infinity. So we can find the inverse. Let's try to complete the square. We have y is equal to x plus 1 all raised to the power of 2, then minus 1. So we can make x the sort of formula here. This becomes y plus 1 is equal to x plus 1 raised to the power of 2. We can find the square root of the function. That is x plus 1 now becomes the square root of y plus 1, and x becomes the square root of y plus 1 minus 1. So on interchanging x and y, we have our inverse to be equal to square root of x plus 1 minus 1. So this gives us the inverse function as required. You can run the same check that we did in the first question and you will realize that you're going to be getting exactly the same answer. You're going to be getting x on substituting the original function into this new inverse function that we've obtained. So with this, we've come to the end of the questions on functions. And in the next video, we'll be looking at limits and we'll be solving questions on limits. See you guys.